Hello everyone, I'm Yazan Ibrahim, or as some of you might know me, Yazan Abu Ghosh. Today we're going to dive into a fascinating and essential topic, Information Systems Implementation, Chapter 3, Part B. Whether you're an aspiring IT professional, a seasoned auditor, or just curious to understand how technology integrates into business environments, you've come to the right place. Buckle up because we're going on a journey through the process of bringing systems to life, beyond the development stage and into the real-world production environment. Let's begin. When you hear the phrase information systems implementation, what comes to mind? For many, it's the excitement of launching a new system. It's the moment when a project that has been carefully planned, built, and tested finally crosses the finish line. But implementation isn't just one event. It's a highly structured stage full of critical steps. This is where the system is installed, tested thoroughly, and integrated into its new home, the production environment. This phase ensures not only that the system works, but also that people, the end users, are properly prepared for its arrival. Think of it as orchestrating a grand performance. The curtain rises only when everything and everyone from the backstage crew to the lead actors knows their role. Let's break down what happens during this critical phase. At this stage, implementation, several fundamental tasks take place. 1. End users, or those who will work directly or indirectly with the system, are notified. 2. Data enters a critical transition through entry or conversion, ensuring that the system gets clean, validated inputs to begin operations. 3. Comprehensive training prepares users to interact confidently and efficiently with these new tools. 4. Post-implementation reviews assess whether the system is truly delivering as planned or if adjustments are necessary. Implementation is more than a handoff. It's the bridge between planning and reality, where you can see the impact of months or even years of work. But before a system can securely transition into production, it has to pass through a challenging gauntlet of testing methodologies. Testing, as many IT professionals and business leaders will tell you, is the backbone of successful deployment. It provides stakeholders with one priceless thing: confidence. Confidence that the system will operate smoothly as intended and deliver the benefits it promised from the very beginning of the project. To meet this goal, organizations must choose the appropriate testing strategies, build plans that align precisely with project requirements, and secure the resources to carry these plans out successfully. This is where the role of an IS auditor becomes particularly crucial. An IS auditor isn't merely a passive observer. They're like the skilled referee in a high-stakes game. They understand the nuances of various testing methodologies and recognize how quality assurance, QA, can strengthen not just the system, but even the broader processes behind it, like project management, software development, and IT services. A well-executed testing phase doesn't just confirm functionality, it validates that all procedural, technological, and operational pieces are working harmoniously. In other words, it verifies that the big picture comes together beautifully. Testing in action. Let's explore how testing operates in detail. Testing a new or modified system involves several classifications. Think of these as different lenses to examine and polish the system before it faces real-world usage. 1. Unit testing. Picture the system as a giant puzzle with individual pieces representing specific programs or modules. Unit testing ensures each tiny piece works as designed, focusing on its internal operations. Only when these foundational elements pass inspection can you start assembling the larger picture. 2. Integration testing. Once those individual puzzle pieces are ready, it's time to see how well they connect. Integration testing examines the intersections where data flows and components communicate. Does one system module pass data correctly to the next? Are there any points where the process falters? This step is critical to avoid downstream bottlenecks later. 3. System testing. Now the whole puzzle comes together. System testing examines the assembly as a cohesive whole. What happens if the system encounters a sudden disruption? Is it equipped with the security controls necessary to safeguard sensitive information? Will it handle high-demand usage during peak times? This stage includes specialized tests like recovery testing. Can the system bounce back from failures? Security testing. Are access points secure? Can it ward off potential vulnerabilities? Load and volume testing. How does the system perform under both normal and extreme workloads? Performance testing. Does it measure up to systems of a similar caliber or standard? 4. Final acceptance testing. This might seem like the finish line, but it's really the moment all stakeholders validate the results. divided into quality assurance testing, QAT, for technical performance and user acceptance testing, UAT, for real-world usability. This phase ensures that the solution doesn't just work, it works well for those who will rely on it. UAT and the human element user acceptance testing is the moment when the curtain rises for the grand debut. Here, end users simulate real-world business scenarios with the new system. Imagine walking into a fully staged rehearsal, complete with props, lighting, and costumes, to ensure every small detail aligns as planned. Unlike earlier tests, UAT focuses on functionality instead of the technical underpinnings. This means evaluating how the system fulfills user expectations. It reveals whether business processes flow as they should, and verifies integration into other routines. As UAT progresses, testers document scenarios, review results, and rig their processes to simulate live use cases, all in a secure staging environment. Minimizing risks with integrated testing. Even after an intense validation process, certain organizations go one step further, relying on integrated test facilities, ITFs. Think of these as test environments disguised as mini production communities. They mimic dynamic real-life interactions such as peak volume and user concurrency. This ensures that potential risks are minimized before the system debuts officially. The IS auditor's role for an IS auditor. Implementation success means asking hard questions. Does the system reflect user requirements? Are key internal controls operating as expected? Are there gaps in testing or documentation that could jeopardize success after deployment? An IS auditor doesn't just review. They conduct interviews, rerun critical tests, validate security protocols, and recommend fixes for vulnerabilities. Their ultimate role is to ensure that the business goes live with a system that is robust, secure, and tailored to its needs. Nothing less. Information systems implementation brings visions and blueprints to life, translating them into functional solutions that fulfill organizational goals. It's a carefully orchestrated process, combining rigorous planning, thorough testing, and human collaboration to mitigate risks and maximize value. After all, a system isn't just about hardware or software, it's about empowering people and processes to achieve something greater. Thank you for joining me today to explore this fascinating topic. If you're passionate about technology, learning, and growth, stick around. We have plenty more to dive into. Stay curious, keep learning, and I'll see you in the next video.